Hello once again. Today I have something a little different for you. We're taking a look at a vintage kitchen appliance. This is a Sharp Carousel II convection microwave oven, model R-8460, and it was made in 1985. I got this thing last weekend from a restore, and it was there with a $20 price tag on it, and it looked pretty good. And I realized that, this thing could have just as easily not worked. But I figured, you know what? If I bought it and it doesn't work, I eat the $20 and at least I tried. It's not a lot of money to lose. But if I bought it and it did work, I had one freaking cool vintage microwave oven. So I decided to do it. And I am very pleased to report that this thing works absolutely perfect. It did have one minor issue that I had to repair, and I successfully repaired it. I'll talk about that in a few moments. But this thing is now working beautifully, and it's in great condition, and I got it with all of the original stuff it would have come with. I got it with the original owner's manual, the original cookbook, the original baking racks. I got this thing with everything. Given how nice shape this thing's in, it's in really clean condition. And given that it actually had all the original stuff with it, whoever owned this thing in its original life, this just must have been the pride and joy of somebody's kitchen. They probably paid $600 or $800 for this. And they really cherished it and took very good care of it. And now I'm reaping the benefits of that 35 years later. That, I think, is pretty darn amazing. Humorously, it also came with another rack, which does not belong to it, a manual for a Kenmore microwave oven, and the easy use charts for said Kenmore microwave oven. So I got some stuff that that isn't meant to be with it as well, which is kind of funny. But yeah, that's really awesome. Now, this thing's pretty special. It is a convection microwave oven. And what that means is it's not only a microwave oven, but it's a convection oven, so a standard oven that uses a heating element. So in addition to all the microwave guts, this has convection oven guts. It's got a heating element. It's got a secondary fan to circulate heat generated by the heating element. And it works just like an oven. You program in a temperature, it does preheating, and it cooks just like a convection oven. So this thing is really cool. It's sort of halfway between a toaster oven and a full-size oven. And I think it's just amazing that both cooking modes of this thing are still working perfectly. This thing had one problem when I got it. Actually, the problem arose after I did the initial test of this thing. The initial test went great. What went wrong was the temperature sensor of the convection portion had failed. The first time I tested the convection cooking, it worked fine, but the second time I tested it, the temperature sensor failed, and the oven always thought that the convection portion was at 430 degrees Fahrenheit. So the convection cooking portion of this thing was rendered ultimately, for the most part, useless. So, I managed to fix that. The core component of the convection temperature sensing in these and similar microwave ovens is a thermistor. A thermistor is a really basic, cheap electronic component. It's a resistor whose resistance changes with respect to temperature. The common type being an NTC, or negative temperature coefficient thermistor, meaning that the resistance of the thermistor lowers as it heats up. So that part had failed in this thing. And I was able to get to it easily. You take the cover off the microwave, and the thermistor was right on top with two wires coming out of it. It was in a little metal assembly that's held on with two screws. Undo the screws, pull out the assembly, and the thermistor's there, soldered to a couple of pins. It was very charred and burnt looking, and there was some crud on one of the legs, and when I scraped one of the legs to get the crud off it, that leg fell right off. It fell right out of the body of the thermistor. So clearly that thermistor had reached the end of its life. I'm sure being in such high temperatures as a convection oven does not lend itself to very long lifespan of a thermistor, at least a poor quality one at the very least. So, as luck would have it, the service manual for this microwave and its higher-end sister model, the R-8560, is available online. So I got the service manual, and the service manual does not tell you everything you need to know about the thermistor, because they expected if you need a new thermistor, you would just order it from Sharp. Well, obviously you can't do that anymore. There's lots of websites that used to sell replacement thermistors for these. Now all of them say out of stock. But what the service manual does tell you is what the room temperature resistance of the thermistor should be. So I had that, and as luck would have it, before I broke the leg off the thermistor, I did measure the resistance, and so I knew the resistance of what it should be when the microwave thinks it's at 430 degrees Fahrenheit. So I knew 2 different resistance values, which is good because when you buy a thermistor, you need to know not only the room temperature resistance, but also what's called the B value or beta value. The B value denotes the shape of the curve of the thermistor's resistance with respect to temperature. An NTC thermistor's resistance drops in a logarithmic curve with respect to temperature, and the B value denotes how steep that curve is going to be. So I knew the room temperature resistance, and I knew one other resistance at a given temperature, so I was able to roughly calculate the B value I needed. So I went on DigiKey and I bought a few thermistors of different B values around the rough value that I calculated, and I decided to give them a try. When they arrived, I put the first thermistor in. I bought an oven thermometer from Canadian Tire, and I stuck it inside this thing, and I tried it at each of the available convection temperatures. And the oven ran routinely 25 to 35 degrees hot. So the B value of that thermistor was too low. I needed something with a higher B value, which makes the logarithmic curve steeper so that the resistance drops faster with respect to increasing temperature. So I tried a second thermistor with a higher B value, and for about half the oven temperatures, the temperature was perfect. For the other half, the upper half of the temperatures, it was 5 to 10 degrees hot, which I am perfectly okay with. And so that was the ticket. I soldered in that new thermistor, tested all the temperatures, and this thing, the convection portion of this thing, is working perfect once again, which I am very happy about. So, if you have a Sharp Carousel II model R-8460 or model R-8560, whose temperature sensing thermistor of the convection oven has failed, the thermistor you need is a 200 kiloohm B equals 3892 DO35 package thermistor. DO35 is commonly what Zener diodes are packaged as. It's a little glass package, which is what you want because it's durable against in high temperature environments. And this cost me like $1 or $1.10. So there you go. And it's been working awesome. I soldered it in with high temperature solder that I also got from DigiKey for this very purpose. And yeah, it's working fantastic, and I'm very happy. So this oven is now working perfectly, both the microwave portion and the convection portion. I think that's pretty darn fantastic for being 35 years old. So let's take a look at this thing. I'll show you inside first. The original interior light works just fine, and while I was inside this thing to repair the thermistor, I saw that it's actually a replaceable bulb. It's a screw-in intermediate base bulb. Whereas a lot of modern microwave ovens now, the bulbs are actually hardwired. They're soldered in. The next thing you notice is how big this thing is. This thing is huge. 1.6 cubic feet. This is a huge microwave oven. Commercial microwave ovens are often this large. And oh boy, this thing is freaking heavy. This thing weighs 73 pounds. I nearly died getting this thing up a flight of stairs into this apartment. It has been sitting on this coffee table since I brought it home a week ago today. And it is not moving until I'm done this video. And then it's moving to the cupboard in place where my current modern microwave sits. And once it gets on the cupboard, it is not moving again unless absolutely necessary. This thing is traumatic to transport. But I managed to get it on this coffee table. You can also see this is a big, beautiful wood grain cube. Wood grain everywhere. It's awesome. This thing looks so nice. It's got a really pretty vacuum fluorescent display. It's dual color. It's got filtered white and red. There's a red element there. Very nice vacuum fluorescent display. You can also hear the beeps. Different style of beeping than what modern microwaves have today. I think it sounds pretty cool. And here's your control panel. Definitely a different layout than modern microwave ovens. For example, these orange buttons here denote the microwave power level. So whereas on a modern microwave you'd hit power level and then you'd hit a number for that power level, this thing has 5 power levels and you just punch it in directly, which is pretty neat. Your number pad is on the right. The number pad doubles as the temperature selection for the convection oven portion, from 100 to 450 degrees. When you want to microwave something, it's as straightforward as any modern microwave, and in fact I'll demonstrate it here. I've got a mug of water, which I will put in. Oops. And you just punch in your number and hit start. You can see. If I want to microwave at a different power level, punch in your number, hit the power level, and hit start. So there you go. If you want to use the convection oven, you hit convection, you punch the temperature you want, say 300 degrees. Says it right on the display. This display is really cool, I've got to say. It's got a couple of graphic enunciators and a lot of text enunciators on it. And the number portion is actually alphanumeric, so not only can it display numbers, but it can and does display letters. And this thing will often give you text messages for certain functions, which is pretty darn cool. So we punched convection and punched in our temperature, and we hit start. It's got a secondary fan. It's got 2 fans that are blowing right now. The cooling fan that operates for microwave mode as well, and then a second fan at the top that circulates the heat around. And you can see it's currently preheating, and the temperature display is actually going up. It's telling you in real time what the current temperature is. See that? And once it gets to the temperature I set, which in this case was 300 degrees, it'll beep to signal you that the preheating is over, and now it's just maintaining the selected temperature. You can also do timed convection cooking. Punch in your time, hit convection, your temperature, and you can see the little fan symbol here actually spins around, which is kind of neat. If you want to do timed convection cooking, but you also want to do a preheat cycle, that's easy to do. Hit convection, hit your preheat temperature, then punch in how long the cooking is going to go for. we'll just do 10 seconds, hit convection again, and then press the temperature to maintain. And then hit start, and it's going to preheat. Oh, it's actually... So the oven's actually already at 150 degrees, so the preheat cycle's actually over. So I'm going to open the door. I'm going to put in my food to be heated, and you can see that it's prepared to 10-second timer. And then I just hit start. And that oven is indeed quite warm in there. Oops. Very cool. So that's how to use the convection cooking. Let's go up here to Compu defrost, one of the most celebrated features of this thing in the manual. So of course, because it was 1985, anything with at least 3 transistors in it was a computer. And the manual in this thing talks optimistically about this thing's computery powers. It mentions its quote-unquote computer brain because of all the electronic functions. And of course, they had to do it. The defrost feature in this is called Compu defrost. So I've never been one to use the defrost feature on a microwave oven, but what I can tell you is that the defrost function in this is quite a bit fancier than the defrost function on your usual modern microwave oven. Because the Compu defrost here, it's got 5 programs, and you hit Compu defrost, and it says food on the display, and then you pick your program. Let's say I'm defrosting ground meat, so I'll hit 3, and it says Compu defrost 3, and the pounds symbol is flashing. It's prompting me to put in a weight. So let's say I have half a pound, so I'll hit 0.05, so half a pound, and it says Compu defrost there, and you get a little snowflake symbol, which is kind of adorable. And once you hit start, it uses the weight you put in to calculate the time it runs for, like any microwave. But the Compu defrost programs are multi-stage. It'll heat up for a while, and then it'll stop, and then it'll give you text instructions on the display of what to do to the meat. Whether it be flip it over, or cover some portions of it, or stuff like that. It's really cool. Let me show you in the manual. So this example in the manual is for defrosting a 2-pound steak. So it tells you to select program 2, which is for steak and chops. And you put in 2 pounds and you hit start. And it calculates the time to heat to microwave 4 in the first stage. And then it stops. And then it says turn over, cover edge. So it actually tells you turn the steak over and then cover the edges, because of course, as usual with microwave cooking, the edges of something will cook faster than the thicker part in the middle. Now, what kind of surprised me here is that when it says to cover something, it means to cover it with tin foil. Now, I was always taught never ever put anything metal in a microwave, and whenever, every single time in my life that I ever saw something metal accidentally put into a microwave oven, the results were violent. A lot of sparking and plasma, and if you didn't catch it quick enough, a destroyed microwave oven. But this thing in the manual and the cookbook invite you to responsibly use tinfoil and other metal utensils in the microwave, not only for convection cooking, but for microwave cooking. All it says is to not cover too much, because you still want something exposed to absorb the microwave radiation. And keep your metal stuff away from the bottom, top, and sides of the inside of the oven so that they don't arc over. So this is fascinating, and I don't know if I'd ever have the guts to actually try that, but the fact that this invites you to do it is really neat. And now I'm wondering if all the times I ever saw metal wreak havoc in a microwave was just because it was too close to the bottom or the sides or what, I don't know. These baking racks, are actually able to be used in the microwave mode as well. Actually, it tells you that you shouldn't use them strictly for microwave cooking, but you can use them for what's called combination cooking, which I'll explain later. Combination cooking are programs built into the microwave that use both the microwave and convection cooking portions. So you can use these for microwave cooking, just not for straight microwave cooking. And as you can see, the legs of the racks have these metal parts on them, or have these plastic feet on them rather, to keep the metal parts off of the bottom of the oven. Maybe it has to do with the fact that this is only a 700 watt oven. Modern microwaves are usually in the 1000 to 1200 watt range. This is only 700 watts, and it's a huge 700 watt microwave. So maybe that alone allows metal to be used because there's not as much power to arc over onto it. I don't know. The manual does acknowledge that metal used irresponsibly will cause the oven to arc, and that it basically says if you want to try something metal in the microwave, try it. If it arcs, don't try it anymore. So yeah, the reason you cover the edges with tinfoil is because the microwave energy bounces off the tinfoil, but the part that's exposed continues cooking. And then you hit start, and then it cooks again for another little while, calculated based on the weight. And then it stops and it says, look, cover edge, meaning examine it, see how it's cooking, and then cover any portions that are reasonably defrosted. And then hit start again. And then it does the third stage. Again, the time computed based on the weight you entered in. And then it stops and it says stand, meaning just let it sit in there for a couple of minutes before you take it out. Very cool. So that's the Compu defrost. And each of these programs has different text instructions and different time calculations based on which program you choose and the weight you put in. Very, very neat. No modern microwave I've ever seen has the defrost function be that fancy. Usually when you hit defrost, the microwave will ask you to put in the weight, you put in the weight, and then it just starts cooking for a calculated period of time, and then it stops and that's it. This thing goes quite a bit further than that, which is really cool. So that's the Compu defrost. So we've looked at the orange buttons, which are your 5 power levels. Another neat feature of this thing is you can actually use multiple microwave power levels in sequence. For example, let's say I want to cook on medium power for 10 seconds and then cook on low power for another 10 seconds. Well, I punch in the time and then hit medium. Then I punch in another time and I'll hit low and then hit start. So it's cooking on medium for 10 seconds. And now it's cooking on low for 10 seconds. So that's pretty neat. And I wonder if you can layer more than 2. Like, can I hit 10? Actually, let me choose a shorter time. Can I hit 5 medium, 5 low, 5 high, 5 medium high? Will it do all that? And then 5... No, it does 4 in a row. So that's medium. Now we're on low. Now we're on high. Now we're on medium high. That is so cool! Man, they really thought of all the exceptions when programming this thing, when designing the electronics of this thing. That's really neat. Another thing you can do is combination microwaving and convection cooking. For example, I can program in a sequence. Let's say I want to microwave something for 10 seconds. And I'll choose high power because you want to specify the power so it knows you're microwaving. And then I'll punch in another time and hit convection at 150 degrees, and then I'll hit start. So now it's microwaving for 10 seconds. And now it's convection cooking for 10 seconds. That is really rad. I don't know if there's many things, many situations where you'd want to cook something like that, but I think it's really cool that you can. Let's talk about these red buttons down here. Starting at the bottom, we have slow cook. And this runs the oven at a low temperature of your choosing, 300 degrees or lower, for 4 hours. And that's useful because the microwave's timer cannot do 4 hours. You can't punch in 4 hours. The best you can punch in is 99 minutes and 99 seconds, so an hour and 40 odd some minutes. But you hit slow cook, set your temperature up to 300. If you try to go higher, it says error. And you have to clear it and do it again. And then you press start and it goes for 4 hours. Very nice. The next red button is broil. This runs the oven at 450 degrees. That's it. You punch in your time, you hit broil, and then you hit start. Oh, you can actually broil. Well, that's interesting. Apparently, what's the point of this? So you have a broil setting. I guess it just defaults to 450, but you can set it at any temperature, which makes it not that much different than just using the convection setting. That's kind of funny. The next two buttons, low mix bake and high mix roast, are combination microwaving and convection cooking. Low mix is 350 degrees convection cooking with low microwave power, and high mix is 375 degrees with medium low microwave power. And of course you can change the convection temperature if you wish. If I hit low mix, put in a time first and then hit low mix, it says 350. I can punch in any temperature and then hit start. And that's pretty much all the cooking functionality of this thing. We have 3 buttons on the next row near the bottom here. On the right, of course, is your stop clear button. In the middle is a button you use to set the clock, but it also sets the automatic start feature. You can punch in a time. For example, right now it's 7:02. If I want it to start cooking at 7:03, I punch 7:03, hit auto start, and then I put in the time and how it's going to be cooked. I'll just do 11 seconds on high power, and then I hit start. And nothing happens because it's not going to start until 7:03. There you go. Next is a button timer and hold. Like most modern microwave ovens, you can use this thing just as a general timer. Punch in your time, hit timer, and it automatically starts counting down. There's no cooking happening, it's purely a timer, for timer's sake. Hold is a function that is used for cooking. When programming a cooking sequence, it just means don't do anything, and you can specify how long it doesn't do anything. For example, I can microwave for 5 seconds, and then hold for 10 seconds, and then convection cook for 5 seconds at this temperature. And when I hit start, you'll see there, now it's holding. There is no cooking happening, it's just spinning the turntable and running the fan. And now it's convection cooking. And now it's done. So that's what the hold function is for. And then finally, of course, you have the start button, but then you also have minute plus. This just adds a minute to the timer while you're cooking. And that's it. That's all the functions of this thing. Here's the back of the unit. It was quite grimy when I got it, but backs of microwaves are always grimy because condensation comes out of the vents, or steam comes out of the vents, then it condenses and it falls on the back, and you get little grease spots on the back. This was full of them, but I managed to clean it up really well just with soap and a Scotch-Brite pad, and it cleaned it up really well and without too much elbow grease, which I certainly appreciate. But we can take a look at the back here. This did have print on it before I went at it with the Scotch-Brite pad, or I tried not to, but I think the soap kind of washed the print away. But you can see down here it says, "Caution, microwaves." And here's the info plate. Sharp model R-8460 microwave oven for household use only. 117 volt AC, 1.5 kilowatt, 60 hertz single phase, output 700 watts at 2.45 gigahertz. Test load 275 cubic centimeters or milliliters of water. And this was made in Japan. Generator, Magnetron, manufactured August 1985. And very short serial number, it's only 5 digits long. This is serial number 1202, so maybe the 1202nd unit made of this model. Oh, of note, modern microwave ovens will hide the magnetron down here somewhere. This one, it's right here, adjacent to this vent. If I shine a flashlight down here, that you can see through the vent grill is the magnetron. It's right there. Certainly helps to cool it though, I imagine, because the cooling fan's right behind it. So I've learned since acquiring this thing that there are two things that the peanut gallery will question you about when you talk about something like this: safety and efficiency. I'll talk about efficiency first. I was surprised. I shared a picture of this thing on Retro Machines, the vintage computer and occasionally other electronic things Facebook group that I'm a moderator of. And I posted a picture of this thing, and not one but two people said, "Why would you want to use that thing? It'll use so much more energy." Well, will it really though? First of all, I use a microwave oven maybe a few, as in less than 10 minutes a week. So add it, no matter how much power this uses, add it up over the course of a year, and it's not going to be very much on your electric bill. But I decided to take a kilowatt meter, and I measured both this microwave oven and my modern microwave oven. This unit is rated for 700 watts output, and it draws 1450 watts from the wall while microwaving. My modern microwave oven that this will be replacing is rated for 1000 watts output, and it draws 1600 watts from the wall. So this thing, when you do the calculation, has an efficiency, I forget what the number came out to, but 48%, whereas my modern microwave was around 64%. So this thing is less efficient than my modern microwave oven. But I decided to do some calculations. I took the power consumption of this thing, did a division to account for less power and less efficiency, multiplied it by the use that I would give something like this over the course of a year, multiplied it by my local energy usage cost, and as it turns out, using this microwave will cost me about $1.80 more per year than my modern microwave oven. $1.80 over the course of a year, and that was using very liberal figures. I think I'll be okay. I don't think this thing will bankrupt me with its electrical usage. The second concern that not only came up in my Facebook post, but also in general I see all over the place with vintage microwave ovens, is the safety regarding microwave radiation leakage. A microwave oven, of course, is basically a powerful radio transmitter at 2.4 or 2.5 gigahertz. And that radio transmitter is inside a big Faraday cage. Microwave's basically a big Faraday cage. You see these little dots in the door? Those form a waveguide. These allow you to see through the door into the microwave oven. There you go. Without the electromagnetic energy being blasted at you. And that's because at the particular frequency a microwave oven emits, the wavelength of the radiation is larger than these little holes you see. So the radiation cannot get past the door. So a microwave's a great big Faraday cage designed to not let any microwave energy out. But of course, if that microwave has been damaged in some way, or if it wasn't designed very carefully to begin with, some microwave ovens can emit microwave radiation to the outside. And of course, that's a concern, especially with vintage microwave ovens, because, you know, if they've had any damage to the door or anything, it could be a legitimate concern. So the question is, could this microwave potentially be leaking radiation every time I use it? I don't know. Visually, I would say no. It's in perfect shape. The door's not damaged in any way. The door lines up perfectly. If you look at the inside of the door, this part right here is the part that blocks the radiation from coming out, and it's not damaged. I've seen YouTube videos of microwaves where this is chipped or broken or cracked. This isn't at all. So I would think that Sharp knew well enough in 1985 to design a microwave oven that would have a minimum of microwave leakage, as they call it. But I do want to find out for sure, so I have purchased a microwave leakage detector. It is on its way here. And I figure when it comes, I'll make another YouTube video, and I will test both this microwave and my modern one, and see if either one has any measurable leakage, and if so, how do they compare. And I'll be able to be at ease to find out if this thing is fine to use. If I test this thing and it's not fine to use, I do not know what I'll do. We'll burn that bridge when we come to it. But yeah, those are just a couple of concerns that the general public will often have when you show them a vintage microwave oven. As for myself, I'm not too concerned, especially, well, obviously I could not care less about the whole efficiency thing. I use a microwave oven so little. But I do care about the safety, but I'll be very surprised if this thing has any measurable microwave energy leakage. But we'll find out in a future video. Well, I've covered everything I want to in this video, which means it's time to finally lug this thing onto my kitchen countertop and just start using it. But I figure I'll show you for comparison's sake. Here is my modern microwave oven. It's Danby, made by Galans. Of course, these are everywhere. You probably have one of these, I'm confident in saying. Galans is the biggest microwave oven manufacturer in the world. They manufacture at least half of the world's microwave ovens now. And I've seen so many of these over the years, and Mom and I have gone through 2 or 3 of them over the years. They generally don't last more than 8 or 10 years. I've never seen one last longer than that. This one's 8 years old and still working just fine. But you can see the size difference. This is a pretty generously sized microwave oven. It wasn't a compact model, but you can see it's just dwarfed by this thing. So this will be kept as a spare. And this thing, I've got to prepare my back. It's gonna go on the cupboard, so I'm not looking forward to that, but I am looking forward to finally having this thing installed and being able to use it. So let me go do that, and when I'm done, if I'm still able to stand, we'll find out how it works. Alright, after a minor setback in which the mug of water that I completely forgot was still inside the oven spilled out all over the inside of the oven, and luckily mostly the floor, I got it all cleaned up, and now this thing is in its resting place. And I think it fits really, really well. And despite its larger size, I actually have more counter space now because I used to have a toaster oven in this space, but I don't need that anymore. This thing will do that duty. So there you go, finally. That is a look at a Sharp Carousel II convection microwave oven from 1985. I think this thing is really darn cool. I really do. I love it. So once the microwave detector comes, we'll do a follow-up video testing this thing for any unreasonable microwave leakage. But aside from that, I hope you guys enjoyed the video. Thank you very much for watching, and I'll see you next time.